Keppler, and I will discuss about AI consciousness in the light of new insights into the functioning of the brain. Though the agenda of the talk is as follows, I would like to start with some challenges in AI consciousness and outline a reasonable scientific path to AI consciousness. And then I will present new insights into the functioning of the brain, which will shed new light on the formation of conscious states. And at the end, we will take a look at the implications of this mechanism for AI consciousness. So let's start with some challenges. Well, this is me, a representative of the human species. And like all of you in the audience, I'm a sentient being who is endowed with an inner experiential world, which means that we experience conscious states. And for me, the defining characteristics of conscious states are phenomenal qualities, or qualia, which means that any state of consciousness is distinguished by the presence of qualia. Well, for some years now, there are robots with advanced cognitive capabilities and human-like behavior, and that's why we are here. One of the big questions is, well, if a robot like, for instance, here Sophia, developed in the Hanson Robotics Labs, looks happy and talks about happiness, are we really dealing with a sentient being that lives in this inner experiential world and enjoys moments of happiness? Or put differently, can robots really exceed the threshold of consciousness? Well, first of all, I personally think that it's of great importance for our society to be able to give a clear and reliable answer to this question. But how can we ever arrive at a reliable answer? My conviction is that we must follow a strictly scientific path, and such a path implies that there is no reason whatsoever to believe or to infer the presence of phenomenal consciousness from the cognitive capabilities or the assertions or the behavior of such a system. Instead, I think the only path that leads us to a reliable assessment of whether robots are endowed with phenomenal qualities requires us to decipher the fundamental mechanism underlying conscious systems. And the most promising strategy to approach this goal is to study the brain and unveil the brain's functional principle involved in the formation of conscious states. And at the end of the day, it's by understanding this principle that we will gain insight into the features, the distinctive features actually between conscious and non-conscious systems. And once we have this understanding, this insight can be transferred to other physical systems. So let's follow a scientific route, and today what we observe is that the route still followed by the majority of researchers is conventional physicalism, according to which consciousness is not fundamental, but in some sense derived or emergent. And this is even so, this approach is known to be afflicted with many, many severe explanatory gaps. So in this talk, you will see an approach that is for sure deeply rooted in physics, but at the same time tries to remedy, to really to circumvent in a way the deficiencies of conventional physicalism. And the starting point of this approach is a model that sheds new light on the functioning of the brain. So to this end, we take a look at the cortex and the organization of the cortex. The cortex is organized horizontally in layers and vertically in columns, and it's widely accepted that the basic unit of operation of the mature cortex is a so-called cortical microcolumn. And such a microcolumn consists of typically 80 to 100 neurons, most of which are pyramidal neurons. that are equipped with branched dendritic trees. And these dendritic trees are covered with synapses through which the neurons receive their input signals. So the main message on this slide is that the cortex consists of a vast number of these basic building blocks, these cortical microcolumns, with very, very little variation in size and structure and a typical diameter of 30 micrometers. In the next step, we take a closer look at the structure of such a microcolumn. The microcolumn receives numerous inputs from other cortical areas and the thalamus, and these cortico-cortical and thalamocortical fibers, they connect to the dendritic trees and particularly to the synapses that populate the dendritic trees. And in active synapses, signal transduction takes place through the release of neurotransmitters. That's mainly, but not exclusively, but mainly excitatory through glutamate. A microcolumn has a glutamate pool that is regulated by a certain type of cells. These are the astrocytes, and via axonal output, signals can be transmitted to other regions of the brain. And this is the structure of the cortical microcolumn, and it looks rather complicated, but taking a closer look at it, you see that it can be translated to a simplified structural model of such a column, which includes only pyramidal neurons and glutamate as one principal neurotransmitter. Actually, we are dealing here with two glutamate concentrations, namely a peak concentration that is encountered in synaptic vesicles and an average tissue concentration that is regulated by these astrocytes. So in summary, in a very first approximation from a physicist's point of view, a microcolumn is a bundle of pyramidal neurons encased in a glutamate pool, or more precisely in a glutamate water matrix. I think it's important to note here that water and glutamate are the two most abundant molecular components in neural tissue, and they form a kind of matrix through hydrogen bonds. In the next step, we want to arrive at a field theoretical, at a very fundamental physical description of such a microcolumn. And for this purpose, we need to know that according to quantum electrodynamics, which is a fundamental theory of the electromagnetic interaction, the vacuum is not a void, but it's a vibrancy filled with energy and potentiality. And among other contributions, the vacuum is permeated by an omnipresent fluctuating electromagnetic background field, which is termed the zero-point field. And this field can be mathematically decomposed into a spectrum of normal modes, which are, so to speak, the elementary frequency components of the field. That's a kind of keyboard, a universally existing keyboard in the universe. And now, according to QED, it's this field, this fundamental field with this spectral decomposition that is seen as the ultimate basis of the electromagnetic interaction. Now one can arrive at a QED-based description of a microcolumn that takes into account the interaction between this omnipresent field, the zero-point field, and the glutamate water matrix of a microcolumn. And this description results in equations, as you can imagine, that express the dynamical evolution of this coupled system. And one essential finding of these equations is that upon exceeding a critical coupling strength between the two players, a phase transition is initiated that drives the glutamate pool toward a coherent state. And this critical coupling criterion is tied to the concentration of the molecules. So the message here is that above a critical glutamate concentration, which is always manipulated via neurotransmitter release in the cells, you can induce phase transitions, and these phase transitions rely on the resonant interaction between an omnipresent substrate, the zero-point field, and the glutamate water matrix. So with this finding, we can now build up a functional model of a cortical microcolumn. And in this model, the synaptic vesicles, where we find actually, now by calculation, this critical peak concentration, they form a kind of clusters where such a phase transition is initiated or ignited. Yeah? And this ignition takes place through, as I explained, the resonant interaction between glutamate and the 0-point field. And this interaction has now very important consequences, two important consequences. On the first hand, it leads to a macroscopic quantum state. So this is a state in which all the molecules reside in a superposition of the ground state and the vibrational excitation, which is very important because this is an energetically favored state that is transiently stable against the ambient environment. And on the other hand, most crucially, this interaction leads to a boosting of the amplitude of the resonant field modes. So there is an interaction on the field and it results in a boosting of the amplitude of the participating field modes. So this is what I call the ignition of a microcolumn. And this ignition sets off an avalanche process that drives the whole glutamate pool of the microcolumn toward a coherent state and results in the formation of a coherence domain. And in this transiently stable state, the dynamical properties of such a microcolumn are then fully determined by the tissue, by this average tissue concentration of glutamate. So this is, when you go into physics, a functional principle behind a microcolumn. And the model I present you here is not just a stupid, fancy idea. It's based on a rigorous mathematical analysis that demonstrates the viability of the model and shows that these processes here are actually feasible under the conditions encountered in the brain. But instead of going into the mathematical details, I'd rather like to summarize the conclusions that can now be drawn from this model. And as I explained so far, one conclusion is that quantitative calculations really demonstrate that macroscopic quantum effects are feasible in the brain. More particularly and more specifically, the model really suggests that the functional principle of these basic brain units in the cortex, the functional principle of the microcolumns, relies on the coupling of the 0-point field to the glutamate water matrix. And this suggests that the brain seems to be specifically designed to modify and modulate the 0-point field, where modulation means amplification of selected field modes, selected frequencies. So the picture takes shape that long-range coherence in the brain emerges through a bottom-up orchestration process involving the 0-point field. So the picture basically looks like this here. A stimulus leads to the ignition of selected microcolumns. The ignited microcolumns form coherence domains, and the formation of coherence domains entails downstream effects that lead to long-range coherence. And now we are at a very critical point here in the discussion or in the presentation. Why I am telling you all this? The point is that the initiation of phase transitions, the initiation of neuronal avalanches, the emergence of long-range coherent activity patterns is a key characteristic of the neural correlates of consciousness. So the model here explains the details behind the neural correlates of consciousness. And an essential element of this mechanism here is the resonant interaction between the brain and the 0-point field, which leads to amplified field modes. And this all suggests that it may be not the brain, but the 0-point field that may be the key to the understanding of consciousness. So what are we gonna do with that? What conclusions can now be drawn on the mechanism or about the mechanism underlying the formation of conscious states? So far, I've been talking about this extrinsic physical manifestation of the field. So it's all physics. There is this field. The field can be decomposed into a spectral of normal modes. Each normal mode has a specific frequency. And we are talking here about a formless, undifferentiated ocean of energy. Now I make one metaphysical assumption, and we will see where this assumption will lead us. I postulate that in reality this field is actually a dual aspect entity with an extrinsic physical manifestation and an intrinsic phenomenal essence. So each normal mode is not only associated in this picture with a specific frequency, but at the same time with a specific phenomenal quality. And we are not dealing here only with an undifferentiated ocean of energy, but at the same time with an undifferentiated ocean of consciousness. So in this picture, I accept consciousness as ontologically fundamental, and I take this field to be the substrate of consciousness, the psychophysical backbone of consciousness, so of the universe. Yeah? And under this assumption, starting from this premise, we can now revisit the resonant zero-point field brain interaction. So from the physical perspective, this results in a set of amplified modes. But from the phenomenal perspective, this boils down to the excitation of a set of phenomenal qualities inherent in the zero-point field. So this is now the formation of a unified conscious state that emerges from a previously existing inherently sentient background of consciousness. So, and when you do not know about the field and you look only at the brain, what you see is just the formation of a coherent large-scale pattern which reveals itself as a neural correlate of a conscious state, but you do not see what is happening in the background. And this approach has many, many strengths now. Yeah? It leads to a very transparent, perfectly intelligible, comprehensible, and universal mechanism underlying conscious systems, and to a very well-defined dividing line between conscious and non-conscious systems, in such a way that it obviously requires special conditions to form concrete conscious states, namely the resonant interaction between suitable molecules and the zero-point field, which then leads to the amplification of modes and to the excitation of phenomenal qualities. So this is very intelligible. And the explanatory power of this approach is due to a paradigm shift, according to which consciousness is not seen as a mysterious emergent phenomenon that comes from insentient matter, but it arises naturally, and it is, so to speak, the inherent nature of an omnipresent field that can be accessed under suitable conditions. And this, of course, and that's the last slide, has now, it needs to be tested, and the publications I did have now many, many concrete predictions inside regarding this mechanism that come out of the theory. It needs to be tested. It can be very well tested. There are very specific predictions. But given this is a good approach, of course, there are now very many implications for AI consciousness. The last slide. Yeah? So what I wanted to show is that scientifically really sound consideration supports the conclusion that the crucial condition for generating conscious states lies in a system's property or capacity to tap into the phenomenal spectrum immanent in the zero-point field. And this makes the functioning of conscious systems radically different from the operating principle of present-day computing devices and AI architectures. And by the way, it is also markedly distinct from the functioning of today's quantum computers, which do not rely on macroscopic quantum coherence and on the excitation of field modes. So the message I would like to convey is that, well, in order, given this approach, to create really sentient robots, we need to establish a resonant coupling of the robot to the zero-point field. And this implies two main research directions, namely to get a deeper understanding of this matter zero-point interface and to really find out We know neurotransmitters do the job to really find out what type of other molecules are good candidates for the resonant interaction with a zero-point field, and what kind of architecture is appropriate to regulate the coupling of these molecules to the field. And this, I think, is now a really scientific, a very clear-cut way to the studying, or a good way in studying such systems, and a scientific way to AI consciousness. And I think it, at the end of the day, amounts to replicating architectural and molecular compositional features of the cortex, but not under a computational perspective, but under a physical perspective. And that's what I wanted to convey, and I would like to thank you for your attention.